Hi, I'm Robert, presenting remotely from Berlin in Germany, and today I'm going to tell you about how we organized community curation to get our data in a nice shape. So, hands up, who in the room is an expert in thermodynamics? Alright, doesn't matter. Let me give you a short introduction into thermodynamics and let's take a hike to the mountains. Here you see a mountain lake. Let's drill a channel. The water will flow downhill. So, this mountain, again, flows downhill. What happens here? Downhill. What happens if we put a lot of water here? Flows downhill, but wait, only until it levels in equilibrium. So let's look at the physics. It only depends on the levels of the lakes and on the amount of water you put in here. Here, in the analogy, this is about Gibbs energies of formation and of the concentration of compounds you have in the system. You know what's really cool about thermodynamics? It's independent on the organisms, because it doesn't matter which channel you choose. It's always the same equilibrium. Now here's a mathematical representation of this. I'm not sure if it helps, right? Okay, let us look at the data we actually created here, right? 278 pages filled with tables. Like, really a lot. Let's look at one entry. So you see here the reaction, right? And now there are some values. We are very interested in those. There's some metadata here and a comment about the quality of the data or whatever. So we need to extract all of this into a table to make it a structured format, right? We can't even search this, like a nightmare. So there were some people doing this before us. But after we finished, we got 5,500 data points here, of which the most are apparent equilibrium constants and some are enthalpies. To make this big data set more searchable, we implemented here a prototype where you can type your stuff and it's doing a free text search on all of the fields. We also have an advanced version of this. You type ethanol, it finds it, and then you continue, you get the value. Cool. So I also promised to share some lessons learned, right? And one lesson is expect a return on investment of 2. Only 2. So for every hour I invested, I got 2 for free in return from volunteers, but not more. You have to create curation manuals, which are really, really detailed, pages long, to really detail what it's about. What are you going to curate? How? Then try out the task yourself. Time your flow, and then multiply it with a factor of 2.5 or even 3 to get a more realistic estimate. Make the tasks as small as possible, because that will allow people to do it in the breaks they have. If it's 2 minutes long, the task, perfect. If it's an hour, no one's going to do it. Use Google Sheets, even if it feels wrong. Git, for example, does have a very high technical threshold. Do check-in sheets, so people can keep track of their work, of their time invested. You can keep track of progress of curation. Finally, implement automation. If you can do quality control with a script, script it. Don't do it yourself. Finally, I would also like to share some personal recommendations for you if you're into databases or other open source projects. Open Life Science has a program called openTECR that's really great. Apply for it, you will get a mentor, and you will work through a 16-week program, getting your project to the next step. What else? I can recommend Combine. That's a network for computational modeling in biology. That's really great and open people. Join it if you can. In the International Society for Biocuration, you will find like-minded people. And finally, if you're interested in thermodynamics of enzyme-catalyzed reactions, it should be a no-brainer to join our mailing list. Thank you, and let's keep in touch.